Good morning, ladies and gentlemen. Let's talk about two very, very special right triangles. Special right triangle case number one. Before we get there, let's recall about the equilateral triangle ABC. And we know from our prior study of triangles and our prior study of equilateral triangles that an equilateral triangle is also, ladies and gentlemen, boys and girls, an equiangular triangle. Let's get that stuff out of there. That's annoying. It's equiangular. So therefore, the measure of angle A is equal to the measure of angle B, which is equal to the measure of angle C, and all of those rascals are 60 degrees. We also know, which is very, very, very important about the equilateral triangle, we spent a lot of time on this, that if I have the altitude CD, this segment that is running from the vertex C to the opposite side AB, we can call that an altitude. This altitude, and of course by the definition of an altitude, this angle is 90 degrees. We also know that an altitude is also a median. It's also an angle bisector. Since it is a median, ladies and gentlemen, boys and girls, DB is 1/2 of CB. This is CB, DB is 1/2. And we also know these two little segments are congruent because D is the midpoint. And we know, oh golly gee, AB is equal to CB, property of equilaterals, and D is the midpoint, so DB is equal to 1/2 CB. That's going to be an important property that we're going to use a lot about these triangles. We also know that the measure of angle CDB is 90, since CD is an altitude. I've already stated that. But we know that the measure of angle DCB, this rascal right in here, that's a 30-degree angle, since CD is an angle bisector. We could prove all of this. How do we prove all of this? Given that CD is an altitude, yes, you guessed it. We prove that with congruent triangles. We're not going to prove that because we did that in a few units past. But we are definitely going to use these properties as we did. So let's go to the next page, and what we're going to do in the next page is we're going to focus on this dude right here, this triangle, and we're going to call that triangle a 30, 60, 90 triangle, because this angle is 60, this angle is 30, and this angle is 90. So we're going to call that a 30, 60, 90 triangle. And we're going to show you some very nice properties of this 30, 60, 90. And whenever you look at a 30, 60, 90, please realize that it is exactly 1/2 of some equilateral triangle. And therefore, DB is equal to 1/2 of CB. It's copied from the previous page, ladies and gentlemen. And that the measure of angle CDB is 90, since CD is an altitude, and the measure of DCB is 30, since it is an angle bisector, since this guy right here is an angle bisector. So what else can we say then? Let's pull the shade down. Yep, there you go. What we're going to do here is we're going to define these lengths. We're going to define DB as E. It's going to make us easier. It's going to help us, whoopsie. It's going to help us talk about this. We're going to let this be E. And golly gee, I want that yellow. We're going to let that be E, that side. We're going to let this side be G. And this side here be F, the hypotenuse be F. Well, why is this true? Why is G squared plus E squared equals to F squared? You are absolutely right. Why is that true? Yes, Pythagorean theorem. This is the Pythagorean theorem. And now, I can put, where did this guy come from? Where did this 1/2 f well, E is equal to 1/2 of f because of properties of this 30, 60, 90. E is 1/2 of f. dB is 1/2 of CB, therefore E is 1/2 of f. And I'm going to take this 1/2 of f and I'm going to put it in that rascal right there. I'm going to put it in for E. And now I'm just going to do some algebra. What algebra am I going to do? 1/2 squared is 1/4. F squared is f squared. And now I have this algebra equation, g squared plus 1/4 f squared is equal to f squared. All these random little spots sitting around here. Now I'm going to do some algebra, do some more algebra. I'm going to subtract 1/4 f squared from both sides. So 1/4 f squared minus 1/4 f squared is going to be 0. All I'm going to be left with over here on the left side is g squared. What am I going to be left with? Well, I'm going to be left with f squared minus 1/4 f squared. And if I have a whole of something, if I have 1 f squared minus 1/4, that's going to give me 3/4 f squared. That's a simple algebra. If I have A or whatever, A minus 1/4 A, that's going to be 3/4 A. That's where this rascal comes from. But now I want G. And I know I'm going to square root because I don't want G squared. I want the square root of G squared. So I'm going to square root both sides here. This is an algebra step. Should be used to from algebra class. I'm going to take the square root of G squared. A square root of G squared is G. And I'm going to take the square root of this. The square root of 3/4 f squared. And this is one of the things that we investigated in the prior video about simplifying square roots. Here I have the square root of a product. The square root of 3/4 times f squared. Well, I can write that because of the simplification of square roots, that property, that's going to be the square root of 3/4 times the square root of f squared. We know what the square root of f squared is. That's f. And I know the square root of 3/4 is going to be the square root of 3 over the square root of 4. Hey, what's the square root of 4? 2. So that tells me, that's powerful. That tells me that if I have this 30, 60, 90 right triangle, that the hypotenuse, or that the long leg, is going to be square root of 3/2 of the hypotenuse. So let's go to the next screen and see what we can. Let's see if we can finalize all of these properties of our 30, 60, 90 right triangles. So I have this really nice 30, 60, 90 right triangle here. I have E is the short leg, G is the long leg, and F is the hypotenuse. And I know that the short leg is equal to 1/2 of the hypotenuse. Property of equilateral triangles. What else do I know? I also know that, well, because of algebra, if I multiply both sides times 2, 2E is equal to F. So 2 times the short leg is the hypotenuse. That is also a property of equilateral triangles. Or this is going to be a property of 30, 60, 90. The hypotenuse is 2 times the short leg. Well, what else do I know? What did the last part of the prior screen tell us was that the long leg, right here, is equal to square root of 3 times the short leg. The long leg is square root of 3 times the short leg. Therefore, G in our diagram, G is going to be the square root of 3 times E. Or, what's E? E is 1/2 of F. Therefore, G is equal to square root of 3 over 2 times F. So there's two things that we can say about the long leg. The long leg is either, well, they both are true, but if you are given the short leg, the long leg is simply square root of 3 times the short leg. But if you're given the hypotenuse, the long leg is square root of 3 over 2 times the hypotenuse. Yes, pause a little bit, and if you always go back to the video and that discussion that we had right here, that shows that. Simple Pythagorean theorem property. This kind of generalizes it. That E is 1/2 F, G is square root of 3 over 2 times F, or G is square root of 3 times E. So let that sink in. Take some notes about that. Let's finalize. Let's do this. Let's insert a blank page here, and let's just make some finalized notes about this 30, 60, 90 stuff going on. If I have this as X as a short leg, Y as a long leg, and this is the hypotenuse, X is equal to 1/2 H. Y is equal to square root of 3 times X. That would also tell me that Y is equal to the square root of 3 times 1/2 H. These are the three properties that you need to know. Well, we can do one other thing. Property here is that 2X is equal to H. So those are the four things that you need to know about, and two of them are exactly the same. Two very nice properties of a 30, 60, 90 special right triangle. Good cliff notes on the video. Okay, so let's go to this other special right triangle. Consider the isosceles right triangle, FGH. And here it is down here. I'm looking at this isosceles right triangle here, FGH, where FG is equal to GH, FG is equal to GH. That's by definition of an isosceles triangle. And the measure of angle F is going to be equal to the measure of angle H. F and H are going to be equal. Why is that true? That's a property of isosceles triangles that we studied when we were studying isosceles triangles. And since the measure of G is 90, since I'm talking about a 90-degree angle here, ladies and gentlemen, boys and girls, friends and neighbors, F and H, the measure of F is still going to be equal to the measure of H, but they're going to equal 45 because they have to add up to 90. Why is that true? That's true because of the Triangle Sum Theorem. So now I have this triangle, this isosceles right triangle. I know we can call an isosceles right triangle. What we're going to do is we're going to call that a 45, 45, 90 triangle. Indeed. And we know that the legs are equal to, A is equal to A. We're going to define those legs to be A this time. Why is that true? That's a definition of isosceles. Property of isosceles triangles. Definition of isosceles triangle, actually. And now we're going to define this hypotenuse to be B. And then we have this equation A squared plus A squared is A. That's the Pythagorean theorem. A squared plus A squared is B squared. We're going to do just a little bit of algebra here. apple squared is 2 apple squares is b squared. And now I'm going to do this square root. I want the square root to find b. I'm going to square root both sides. Small little property of algebra here. And I know the square root property here, this is something that we learned in the previous video, is that I have the square root of 2a squared is going to be the square root of 2 times the square root of a squared. Hey, what's the square root of a squared? A. What's the square root of b squared? B. So what does that tell me? Ladies and gentlemen, you're digging dog right. That tells me that b, the hypotenuse, is square root of 2 times the leg. That is in a 45, 90 triangle. Hypotenuse is square root of 2 times the leg. I think on the next slide I have written these notes out, and indeed I have. The hypotenuse is square root of 2 times the leg. This is not very exciting, but OMG, this is important. Both of these special right triangles are important. Special right triangle number 2, special right triangle number 1 was the 30, 60, 90. So let's real quick do a couple quick examples using this. Examples, if I have a 30, 60, 90 right triangle right here, ladies and gentlemen, let's see if I can't get it really ugly looking, where x is the short leg and y is the long leg and 3 is the hypotenuse. I want to find x and y. That's my question. Find x and find y, and that's given the hypotenuse. Well, x is going to be 1/2 of 3, which is 3/2. Why? Because the short leg is 1/2 of the hypotenuse. The long leg, why is this true? Why is y equal to square root of 3 times y is going to equal square root of 3 times 3/2, because the long leg is square root of 3 times the short leg. And the short leg we found was 3/2. Square root of 3 times 3/2 is 3, square root of 3 over 2. And this is the reason why right here. This is our property. And let's do a quick example over a 45, 45 right triangle. This is going to be a 45, 45, 90 right triangle, where I know the hypotenuse is square root of 2 times the leg, and the legs are the same. And I'm given that the hypotenuse is 12. The hypotenuse is square root of 3 times the leg, and I want leg, I want x, so 12 is equal to square root of 2 times x. Now I'm going to do some algebra here, ladies and gentlemen. I'm going to divide both sides by square root of 2 here. And that tells me that x is equal to 12 over square root of 2. And again, what do I need to do? I need to recall the prior video on simplifying radical expressions. I don't want this square root on the bottom down there. So I'm going to multiply 12 over square root of 2 times this guy that we're going to call 1. This dude is 1. Square root of 2 over 2 is 1. There, I'm not going to change the value of 12 over square root of 2. I have two fractions. I'm going to multiply the top. 12 times square root of 2 is 12 square root of 2. Square root of 2 times square root of 2 is 2. 12 divided by 2 is 6. And there you have it. X is equal to 6 square root of 2. And x is equal to y because it was isosceles. So there's two examples of the 30, 60, 90 and 45, 45, 90. Two very, very, very special right triangles. Have a good day.